Hello, my name is Kim Christensen, and today I want to talk a little bit about our ejectors. And I actually brought one with me so you can see how it looks. So this is an ejector. It looks a little bit different depending on what configuration we're using them in, but in principle they are identical. This is the motive port. That is where the high pressure gas from the high pressure side comes into the ejector. This is the suction port. That is where we are sucking from a low pressure level in the system. And this is the mixing chamber, and then we have the diffuser, and then the gas is leaving here to an intermediate pressure level. And the idea is to use these ejectors in our CO2 heat pumps, both air source and water source, and to increase the performance, both capacity but also the COP of the heat pump. We are basically reusing the energy of expansion from the high pressure side to the low pressure side. So that's the idea. But we're using them in two different configurations. And I will just show you. To the left you see the high lift configuration, and to the right the low lift configuration. High lift configuration, we are using basically two compressor groups. One compressor group we call MT, and a second compressor group we call IT. And the liquid is to the evaporators are coming from the receiver. It is injected into the evaporator, and the gas coming out of the evaporator is separated into two streams. One stream going to the compressor, but a second stream that goes to the ejector, and the ejector is lifting it back to the receiver. The gas that goes to the receiver is compressed by the IT compressor, and the gas going to the empty compressor is of course compressed by the empty compressor, and all the gas is going to the gas cooler where we reject the heat into the heated water. If we look at the diagram here, this is a rack in operation. You can see that basically the compressor is sucking at 33 bar, which is basically the pressure here, but the receiver pressure is at 46 bar. So the ejector is lifting 13 bar. This is free of charge just by the expansion of energy from the high pressure side. And it takes more or less 40% of the mass flow. Not all the mass flow, but 40%. So that is quite a gift to have free of charge. The other configuration with the low lifting ejector, it looks a little bit like it's a simpler system, which is probably is, but there are also some complications around this system. But the way it works is that the liquid is coming from the receiver, is ejected into the evaporator, and the gas out of the evaporator all of it is compressed by the ejector and lifted back to the receiver. So as you can see down here on the diagram, the lift is now only around 6 bar because it's lifting from 34 bar to 40 bar. But it's taking all the mass flow, all the gas from the evaporator and lift it back. And there's only one compressor group compressing it back to the high pressure level. It's a little bit more simple with a low lifting ejector, but there are some constraints when or how we can use it. At FENeject we're only using the low lift ejector on water-to-water heat pumps and on air source heat pumps when the evaporators are very close to the rack or the receiver at the same level. So when the distance is higher and there is a difference in height, then it's not a good idea to use the low lifting ejector system. But the performance gain is more or less the same. It could be up between 8-10% using an ejector, so it's really beneficial. So that's what I wanted to tell you today, and I hope you learned something, and I wish you a nice day. Bye.